Hey, what's up guys? I just wanted to make a quick video on using scriptable objects as enums. So traditionally you would use an enum to compare something or to just store some really basic data, but a lot of times it's very common to have a big long switch statement, right? That you look at every single type within your enum to do some sort of logic based on that type. So obviously that's extremely useful in a lot of cases, but if you're not a programmer, it's very difficult to make any change to the game or to add to that list without making a code change is really impossible, right? So the way that this is we're gonna go about looking at it is from a design standpoint. So we would want the designer to be able to use Unity to go in here and make a change to the system without having to ask the coder to add or change something in the code. So let's look at how to set up that system. So we have a class declared as an enum value, and it's just a scriptable object. It has no anything, no logic, no properties, nothing. So what I want to do in this example is a little simple roller ball example. I want to have different types of balls, and those balls, when they hit the different pads, might do something different based on the ball's type. So the first thing to do would be to define the types, right? I mean, the first thing you do in the code is to write the enum. So this is what, well, let's look at that script once more. So we defined an asset menu, and it will just create an enum value for us. So I'm going to go ahead and create 4 new enum values. It's a variable enum value. I'll call this one blue ball. And then I'll create another one for green, another one for, I didn't want to do that, yellow. So this is what your enum will look like. Instead of being in code, it's going to be in these objects, right? And then you'll hook the objects up to different behaviors or systems, and then the logic will be done automatically. So then when you want to add to this list, you don't have to make a code change. You just come in here and you create another value and you give it a name. So that's really what your logic is coming from, defining the name of the thing, obviously, because it's got no information behind it. So the only difference between this object and this object is its name. So again, it's a design from a design standpoint. That's how it works. So in this example, I want to have the ball have a type, and I want the ball to also have a material involved with that type. So I have some basic materials here that that I'll be kind of hooking up to the other ones. So let's look at the ball behavior here. So again, the ball has a reference to that, to an enum value. It's private, but we'll look at how that gets set initially. It has a reference to a ball system, which is also a scriptable object that has all of the definitions of what can I do with the ball types, or how do the ball types relate. So if you remember those big long switch statements that you have all that logic in the switch statement, well, all the logic that might be needed when it comes to either retrieving types or comparing types or all that would go into a system. So that is an example of a scriptable object as a system. And we can look at that here in a second. So really the only thing to know on the ball is that when its type is changed, and we use this public property to, when it gets changed, I'm going to set my private value to what's given, and I'm going to call this change type function. And that change type function is going to use the scriptable system to change, do some work on this object, right? So it's an example of taking logic out of the mono behavior. We're taking information and putting it into a an asset. This is an object that is very autonomous and will do work separate from the scene and separate from any monobehaviors. So in that ball system, we've got a list of details, and so we'll look at that here. The list of details is just, it keeps track, it just links the two of these together. It links a type to a material. So technically, when you start doing this, as soon as you do this, it makes it a good candidate to just make this a scriptable object, and then just get rid of the type, right? Because then really that's all that is, right? Because then you can, instead of just using enum values, you're always using details, ball details. So this is just for example purposes, because of what I wanted to do here. The types still matter, but I wanted to be able to change the material so that we could see what's going on. So in that ball behavior, again, whenever I change the type, it calls the ball system logic. And so that requires the mono behavior to have a reference to the ball system. So these can also be seen as static classes, and you can create static classes. I've used them plenty of times, and they're very useful to just have, I just want one instance, I want one singleton of logic that is in one place that is outside of the mono behavior, and that's great, that's good. But those, a lot of times they're not, they're just not very, they don't hold their state, and they're just not very as configurable. They just don't work as well. I'm sure there's plenty of other advantages of using scriptable objects instead of static classes, but that's a different subject. So, so the system has a list of details that's just going to define which types are just in the system, and then I want to have one value that is my default ball type. And again, that's going back to how a ball gets set. Its original, just right off the bat, start, it sets its ball type to the default ball type. So that's another example of retrieving information out of the system instead of having this value on the object itself, because in the next scene I create another object, and then all of a sudden I have to set all the default ball types on each one of the mono behaviors in the scene. So instead we take that information and we put it into the system, and then we retrieve that information and when we need it from any object that needs it. So let's look at the code, or stop looking at the code and start looking at the example. So first thing to do would be to create the ball system, which is that main monster class here that is going to do all the work and have all of our relations. So in there we've got a slot here for our default ball type, and then we've got a list, and I'm going to create 4 of them to define what my values are. So since I already have the values here, I just went to create the enum values. Go to the ball system, I'm going to lock it, and then just plug in each one of these into the enums slots. And I'm going to give them each their material. And then I'm going to set the default type to be green. So you can already see that this makes it so that the designer can just very easily come in here, create a new type, and then add an element, and then give it some stuff, right? It's that's the whole reason that we're doing this, to save us some time. So on the ball behavior script, we just need to reference that system. So it looks like I've already had it referenced here. So now on start, that ball will call its start routine, and it will use that ball system's default ball type, which I set to green, and we'll set it to its ball type, which should call the change type function, which will use the ball system to call set ball material on this game object. So when I call the set material, it's going to find, well, it's going to get some references, obviously from the object that I'm going to be working on, and then it's going to find within the ball details where the type, this is a enum value, is equal to the ball type. So it's just going to give me from this list which type matches, and then it's going to set the mesh renderers material to that ball type's type material. So if I play here, this should change that ball to green ball. Yep. So right on initialize it did that. So it's working, right? So now whenever the ball hits one of these pads, I want it to change type. But I want to be able to configure that change, that behavior within the engine. So obviously we'll need a behavior sitting on the gate, and the gate is going to have a list of accepted types. So whenever a ball hits it, it's going to check this list, and if the ball's type is within this list, then it's going to convert that ball into a single type. So excuse me, you can see the gate is kind of more like a converter. I should have called it a converter, because it you give it a list of types and it just converts that into that type. So again, that's all it does. It checks on collision, it gets the other ball's ball type, and then it sets that ball type to my converted type, and then it bounces it, obviously. So this here again is hitting that property, right? So it's hitting this property right here, and it's going to call change type, and it's going to call the system set ball material, and then it's going to change material. So let's look at that in action. So we're going to put the gate behavior on each one of the gates. So it looks like it's already there. And so I want to have, let's say, 2 accepted types. I'm going to accept blue and green, and I'm going to make yellow for that gate 1. And which one is that? That's the left one. And on the right one, we'll accept yellow. Oh, sorry. Accept yellow, and we'll convert it back to green. Okay. See if that works. It's already green, so now it should bounce back between the two. Yep. So you saw at the beginning, since it was already green, it didn't make the change, because this one is accepting yellow balls and it's turning them into green balls. So it looks in its list and does that comparison, and it doesn't find it. So it's not going to do anything if it hits over here. But then when it hits the other one, it converts it. And now that it's yellow. Yeah. So there you go. That's really all this is going to do. But again, it just this is the comparison that we're looking at. We're being able to compare values, and we're able to attach those values to objects and add additional values and configure those values all within Unity, not in code. And it just makes life a lot easier for us programmers, and a lot more fun kind of designing systems that work like this. So yeah, maybe we can have some fun here and see what this actually does with a whole lot. And I had some weirdness going on with with the physics that I just haven't looked into. So this should set them all to be green by default, and blue, green, yellow. So we'll change yellow and red into green, and then this one will change green and red into blue, and this one will change yellow and blue into green. Sure, why not? Alright. That should be... Oh, of course it hit the green one. Alright. Yep. Pretty simple stuff. It's gonna... Yep. Cool. So if you have any questions, let me know. I hope this makes sense. And hope to catch you next time.